Okay, we're rolling. So going to be doing a little bit of review today. I think we've learned a lot of things, and yeah, we'll walk through it right here. Taking attendance on everyone who's here so far. Um, so yeah, we've talked a little bit on like the expectations and like Python basics. Very first class, we talked about the data types, variables, functions, libraries, and obviously seeing those in every single class. How we use all of these parts of Python. Data literacy, ability to read, understand, create, and communicate data is information, because that's kind of the important part. I think we talked about a little bit how important data is for companies, but if you cannot translate data into meaningful insights, it's not going to be very valuable for companies. So being able to understand and analyze data properly is very important as an analyst and for companies, because that's what's going to create value for them. Pandas, one of the libraries that we've used almost every single class we've used pandas in some extent, helps us to structure our data into a data frame that makes it a little easier to work. We get that nice tabular format and helps us to clean, transform, and analyze our data sets. And then
is there like a basic like Python library, and then you add things like pandas, and I know there was a few others, I can't recall them right now, and those have other abilities, like you said, pandas does the data frame, right? Or is that the case? Is that what it is?
Yeah, so when we have Python, just like you install Python on your laptop, or you use the Anaconda Cloud. So it can do certain things, like you can do your loops, variables, like that's like the language. So writing in Python without any external libraries, you can build programs. Like we saw that you could do, I think in the very first class we looked at like, how to add numbers together, or like subtract, do exponential. So you can do that with just Python itself without any external libraries. But then if we import our libraries like math, that's gonna give us like the functions that already do it. So you don't have to like do the nitty gritty of what those functions will be doing. And yeah, so pandas, it is a Python library that is just kind of like you think about, so you have, if you've used Google Chrome, a browser, so you add like extensions that can do different things. So you can kind of think of libraries as that. So it just adds more functions and classes into your Python.
Okay.
So with pandas, like we import pandas. So now, like if you didn't import pandas, you wouldn't be able to use the data frame, because the data frame belongs to pandas package. So we have our Python right here, and then pandas is over here. So we have to bring our pandas and like melt it into Python in order to use it. And yeah, last class we talked about like matplotlib and then Seaborn, and yeah, pandas. So those have like the visual effects, or like the charts and different ways to showcase, make plots, charts. And again, you can't do that unless you import those libraries in.
Okay. And I know you mentioned a bunch of these libraries in different ways, but is there like a really good resource to see like what types of libraries are good for different types of functions, or like what you gave? Like, I'm just trying to go back through my notes a little bit, but
I think like, so like pandas, NumPy, and then like matplotlib, Seaborn, like those are like the most popular ones when it comes to like analytics, data science. But if you're looking for something very specific, so for example, like the very first class that I showed you guys, like how I use Python personally to like automate things. So that script connected with my Google account and Google Calendar. So in order to do that, I need to like import the packages in order to do that. But you don't really like, I didn't really know what those packages are. So like, I basically just like Google or like ChatGPT, and I'm like, hey, like what Python libraries do I need in order to achieve XYZ? And that's kind of like, there are like millions of Python libraries.
Like there's not like a list. Like
yeah. Okay. No, there's like, cause like Python is like open source in a sense that like you can create your own, like you can create your own packages and other people can use those. Like you can go on GitHub and find a custom library that provides you, like you can build a library, a package that other people can use. So you can't really, there's not like a list, but like you could Google. So like, let's see, like what are the most popular data science libraries in Python? And you'll probably, you know, here we get like NumPy, Pandas, Matplotlib, Seaborn, Plotly, Scikit-learn.
Okay.
Or we get the AI. Then there's like TensorFlow, PyTorch. So yeah, so it's kind of like if you're starting, let's just say like you decide like, hey, I want to create something in Python. Like you have an idea that you want to do. Okay. You would kind of just Google it, but like, oh, what are the best? And a lot of times there are like multiple libraries that can help you achieve the same thing. So you can be like, hey, like what's the best way? Like what's the best library for this or to deal with this kind of data? So that's kind of like nobody knows all of the libraries. Yeah. If once you get into like data science with Python, you get familiar with like the most common ones. And if you were to like if you weren't a data scientist and you used solely for like application development or like web development, they have their own libraries that are like common and people are like aware of. But that's kind of how. So there's no reason to like, you don't need to like write them down or anything. You'll always. I think
I just kind of missed as you were talking about each of them, like, why am I importing pandas or why am I importing? I think I just kind of missed that. Like now I realize like they all kind of have different specialties.
Yeah.
The thing to learn. Okay. Got it.
Yeah. So depending on what you're trying to achieve, you're going to find a library to do it and then import it in. Okay. So yeah, like here we say like, oh, pandas for data manipulation and analysis. And that might not mean a lot to you if you are not familiar with pandas, but you know, we're going through examples and learning. So like, I will say like, almost every data science project is going to be using pandas because it just makes it easier to like read the data. As we've seen, be able to like the data frames, it just makes it so much easier to deal with it.
Yeah.
Any other questions on that?
No, that's good. Thank you.
Perfect. Yeah, and then went through that. Then just a couple terms here. So Jupyter notebooks. So these are the like notebook. So, and that belongs to Anaconda. So, and again, this might be like a little difficult to explain maybe, but like, so Anaconda is just like, it's a distribution of Python. And what that means is like, you can use Python, like you can just install Python on your laptop and like just use it as it is, use it on Visual Studio, like use it in one of the coding applications. Anaconda, it provides all these like extra stuff to like for Python. So like this is the Anaconda Navigator, and that's what we went through in the end of last class. I showed you how to download this. And so like here we see like Jupyter Lab, Jupyter Notebooks, VS Code, and this one's like, you can have VS Code just like on itself. I honestly like don't use a lot of these, only pretty much just like Jupyter Notebook. And that's that was this thing. So these two, so this is our Anaconda Cloud notebooks, and then this is Jupyter notebooks, and they're both do like pretty much the same thing. The only difference is that this is in the cloud, so nothing's saved locally, and then Jupyter notebooks, this is like everything's locally for you.
Okay.
So this notebook is in a folder on my laptop.
Okay.
And like this data set is locally on my laptop, which you can still use. Like you can go find, like you can use it from a URL, like we've seen in some of the notebooks. But so that is, let's see, yeah. So Jupyter Notebook, open source web application that allows you to create and share documents that contain live code, equations, visualizations. So these are the notebooks that we've been looking at.
Okay.
And then, so Anaconda, yeah. So the one thing about Anaconda is that it includes a package manager. And what that means is like, if you want it, so we have multiple versions of Python. Like whenever they upgrade, like there used to be Python 2, and then there's like 3.10, now there's 3.12, and like every time they make like significant updates, it's gonna upgrade. So those are like the versions, and depending on what version you're using, the code might be a little bit different. Like some things get deprecated, something gets renamed, like some functions just work differently in the newer versions. So like with the package manager, that kind of like lets you install things with the pack, like install the libraries or Python with the package manager, and it's just like helps you manage it. And if you wanted to like use just a certain different version, it does what it manages the packages for you, kind of. So it just like makes it easier. But there's nothing like, it already comes with it. So there's nothing like you have to install or anything like that. But what it kind of means is, because there's like different kinds of package managers. But like here it says like Conda, like that's the name of it. So if you were to install libraries for Anaconda specifically, so like that distribution on your computer, you would do like Conda install pandas. So that's like, instead of normally, like if you're just installing it for your whole laptop, you would just do like pip install. So that's like the difference there. And that doesn't need to fully make sense. It makes, more you use it, less it's going to make sense what's happening. It doesn't really, it's nothing we need to fully know. Like no one's going to quiz you on this, and like you can still do what we've been doing without knowing all of this. And then our cloud-based solutions, so Anaconda Cloud. Then there's also Notable, which I'm not that familiar with. But it just means these notebooks that we've been working with, you can run them on cloud in the web browser, so you don't have to have anything installed locally, which is great if you have an older laptop that doesn't run things efficiently, or you work a lot on a personal laptop and then you work a lot on your work laptop, like work on the same things, same thing as like a Google Drive. It's just, you can all access it from any device. And business intelligence tools, Tableau, SQL, Power BI. Any questions on that?
I don't think so.
No, I don't think anyone's like ever gonna quiz you on what these things mean. So like in terms of will you be able to do your job, these are not that important, but we're just covering them.
I think like in the last two classes, kind of at the start of class, we would download the software that we would use to like code. And so I wondered if that was like, if we did start with Anaconda Cloud, but we're kind of just following along the notebook. So that's just like, I think it's just like me thinking, okay, where do I actually, because like when I do code work, outside of my websites and stuff, like I use like VS Studio, or I use Brackets or something. That's where I write code in. So
Yeah.
like you kind of like equate this, like what would you write this in, or what would you do this in? Like we did SQL Workbench for the last class. Like that's kind of where I'm like, what would I probably be using at my job in the future?
So, so we talked, so this, the local, like Jupyter notebooks, that's my go-to thing. And that's what I've been taught to use. Like whenever I took like any type of data science stuff in school, this is what everyone usually uses. You can open these in Visual Studio as well. So let me show that real quickly. And it works the same way, but I think it's like one of those things where you've, like you learn something one way, you just get like, kind of like, you prefer it. So here we have one of the notebooks that we went over last class. Yeah. So this is the same exact thing. And like, let's see, let's see.
I like that you can like just type in text and have images, and it's like a whole thing.
Yeah, I did want to, let's do a real quick on, so this is what, so do you remember end of last class, we downloaded like the Anaconda Navigator?
I don't
from
I remember. My house was a little bit stressful last week, and it's a little bit at the end of class, but
yeah. So Anaconda, well, we can go this over again. The solution, free download. So here, so anaconda.com/download, and then you can skip registration. It's not download for Mac or Windows or whatnot. So this is going to download the Navigator. Okay. So which is this thing, and it's going to include. It doesn't always include. I think this is like the default things that it includes, but you can also install more applications on here. But like once you download this, then launch Jupyter Notebooks, it will open these notebooks in your browser, whatever your default browser is, and then. This is basically like it pulls up all your folders. So here you can see like where the data cleaning folder is. And here is like the data, like I have my CSV files, and then I have a couple of notebooks here. And then by here, we can create a new Python 3 notebook. And this is just a plain. And this is where we can just start like, import pandas as PD. And then this one's kind of like, so this is this is within the Conda and Anaconda distribution. So I think it comes installed with pandas, but if it didn't, we would like have to install it, which would be like going to the terminal, which you can also do it in Visual Studio. And then, so like here we would do like Conda install pandas, for example, to get the library in the Anaconda. But I think a lot of them are, I might be wrong on that. I think a lot of them are installed, like the basic ones, but then some you have to do. But another thing with these, when you're like creating notebooks, and like if you wanted to create a notebook similar to where, like, where'd you go? This one. Like this is the same notebook as this. Like they're all the same type of file, but this one just has a lot of text. And the way that works is here where it says code. So we can change to Markdown or a heading. So like Markdown is a kind of like a language as well. So it's just like text formatting, basically. So like doing the hashtags, this is a title. So this is what we get. or then we can do a big title. And again, this one needs to be bigger title. So this is kind of like if you're creating a notebook and you want to like share with someone, it's like, hey, here's like all the insights and like the graphs and whatnot that I've done on this data set. And then you want to include like titles, sections, descriptions, whatnot. This is how you can do it with the Jupyter notebooks. And same thing here.
Okay.
Here's where it's like markdown and then code. Any questions on the Anaconda, Jupyter Notebooks, Anaconda Cloud? Is there anything you want me to like walk through to like install that Navigator or anything like that? One second. Let's see. Okay. So we'll go over this. I'm not sure why this is called Python cheat sheet, but this one has a couple examples on what we've done so far. So like last class, we went over a quick example on, you know, a little bit of data cleaning, visualizations. So this notebook, we're going to be using Iris dataset. And this is just a dataset that's used to show like data science things. It's available on GitHub. So it has 150 records of 3 types of irises. And then like information about their sepal and petal length and width. And so here's like the libraries that we have seen and used some of these. So we have our pandas, often imported as PD, and our matplotlib, PLT, Seaborn, SNS. So pandas is the data cleaning one and the data frames. Then matplotlib and Seaborn are for visualizations. Then at the end, we're going to see a little bit we'll do quick little examples on some statistics and then some machine learning very briefly. And these are like popular libraries that are being used for that. And we'll run this. And so here's our Iris data set. So this is where we use like the pandas. So pandas has been renamed as PD. So we do PD. And this could be also pandas, like pandas dot read CSV. So pandas provides us this function to read a CSV file either from a local file or from URL. So this is we can put this we could put this in here, and this is the data set that it's reading. And then here we're gonna our data. So this one returns a data frame. Here we're just assigning, like, we're gonna call it data frame, which we could do it here. But this way we have a copy of like the untouched data. So if we wanted to refer back to what we had before we made any changes, we can call Iris instead of df. To get the columns, so columns equals list, df.columns.values, and then this is splicing, so we only want the first 4 columns. And here we see, did this one? Okay, yeah, these are not happening run. I just ran this. Yeah, so columns. So what this one gives us is like, this gives us all the columns from the data frame. We turn them into a list, and we want only the first 4 of that list. And that is, when we print this out, we get the sepal length, sepal width, petal length, and petal width. And if we didn't do this, we would just get like, oh yeah, I changed this. That's right. So basically what we're not including is the species here. Then the very first class, we went over for loops. So we have a very simple for loop here. So for I in columns, print I. What do we think this is going to output? So I is just, you can call it anything. It could be C, it could be col, whatever. And col would probably be like more descriptive. And this one could be columns. And we do for column in columns. So print col. So this one's just going to print out the name of each column, because that's what we have in the list here. So this data set is like, it doesn't have anything, it doesn't have like dirty data, as in like we would have to do some data cleaning. So what we can do here to like create some dirty data, to do some data cleaning, here what we're going to do is, so we have another for loop, and again, the I is going to be the column. This one, it randomly samples 90% of the data from the column, and then it's going to drop 10% of it. So we're going to get some null values in each one of those columns. And this one is just like, so sample, and then setting it to 90%. And this is not something that you would want to do like if you're doing a real project, because obviously we don't want to make bad data, but we're just making some bad data to make it good again. So here we can see, like, looking at the first 10, so df.head, I'm putting 10 in here. So we want to look at the first 10 rows. We see a couple of null values in here. And then we can look at the shape. So we have 150 rows, 5 columns. So no records have been dropped. Everything's still there. We just have a couple null values in there. And then looking at the data types of each one. So these are floats or decimals, and the species is an object. In this case, it's a string, but object is fine. And then we can use the describe. If you remember, what that does is it gives us some statistics on each one of the columns. So for each column, so sepal length width, petal length width, count. So here we see like each one of these columns has 135 values. And that is because we got rid of 10% of them. So each column has 15 empty values. And that's because of what we did here. Then we get the mean for each one of them. Standard deviation, minimum, 25th percentile, 50th, 75th, max. And yeah, does the count match the number of records? If not, why? We just went over that. And then what else can we look at this? Like one thing that I noticed was like, we're looking at like the mean of each one of these values or each one of these columns. We have a pretty like relatively high standard deviation in comparison to the other columns. So what that means is like the petal length varies the most compared to the other columns. And if we had a really high standard deviation here, meaning we would have a very wide range of, actually, sorry, I'm getting ahead of myself. We'll go over that in a second. So yeah, let's check any questions on this? And that's just like an example inside that we can look at this. And depending on like what you're trying to accomplish, whether it's like, oh, like look, like what's the maximum of the sepal length or whatnot, just different insights. So here we can check the null values, 15, as we talked before. So here again, we're calling pandas is null, sepal length. So how many values in this column are null? And the sum, we're getting the total. So 15, which is 10% of 150. And here we have another for loop. So again, for I in columns, print the column, and then we get the number of null values. And this is the same for all of them because we did the same like loop for all of them where we drop 10% of the values. Then another function that pandas offers us is info, which this is similar. So this one kind of combines like the D types and then like the nulls, column names and such. Because here we can see like column name and then non-null count. So here we can see these 4 columns have 135 non-null values, which means we have 15 null values. And then in species, we have no null values. And we get the float here. So this is the same thing as running the D types. So this one's just like spits out kind of like all of the information at once. Then if we wanted to get rid of the null values, we could do the df.drop_na. And again, this is so our data frame, which means the drop_na is part of the pandas library. And this one, we would only have 103 rows. So we've dropped all the rows that have null values in them. But this one is, if you guys remember, we can pass in here, like if we did in place equals true. This one will actually modify the original data frame versus if you just do df.drop_na, it's going to show you what it will look like. So we're not going to do that. We're just going to, that would just like example if we were to drop them. But we don't want to drop them right now. And here we can look at, so next thing, we've decided that we want to fill those null values with the mean of the column. So we looked at them, we saw them in the describe, but let's look at them again, what we have. So this is the mean of this column, mean of this column, mean. So here we are creating a second, like we're just creating another variable that we're going to just assign the original data frame for. And here, another for loop. So for this column in the data frame, fill the null values with the mean of the column. And this one's going to do it for each one of the columns. So here, we can take a look. So we fill all the null values with mean. So if we look at here, so for example, we had a null value here, and then we had a null value here, null value in 4 and 5. So sepal width, and then petal width in 0 and 2. So here, sepal width matches what we have here. And then petal width on number 2 matches that one. So we filled in the means in the data set. And so what I was saying earlier, jumped ahead of myself with the standard deviation, like if we have a very large variety of values, mean might not make sense in this case because it would not be like accurate anymore. So in that case, we would want to like, we can consider like the Kent neighbor, which we went that quickly over one of the classes, I think second class last week. And that just means like you select like K is you just choose a number like, hey, like get the mean of the closest neighbors to it, and that might give you a more accurate value than like just using the average of the whole data set or like the whole column. So there's different ways to fill it out. But this is, we'll just go with this one right now because the standard deviation is not too crazy. Then removing duplicates, df1, drop duplicates in place. So this one's going to do it to it. So there's one row that had duplicate values. And then another thing we can do is rename the columns. A lot of times when we're dealing with like data in a CSV, the names are usually, you don't have spaces in them and like it's all lowercase or it's camel case. So just to make it like more readable, formal, prettier, we can rename them. So we have df1.rename, and again, this is a pandas function. For columns, we're gonna, sepal length is gonna get replaced with sepal length with title case and with the space. And again, we're gonna do in place true. So now instead of having these headers, we're gonna have proper headers over here. Any questions on this? And most of this we've already seen. So just a different way, different example, how we can apply these functions. Okay, let's do some more visualizations. So Seaborn was one of the libraries that we learned about last week. So here we have seaborn.pydata.org, and this is where you can find examples, everything that's like possible to do with this library. And it also shows you like how to install it, gallery, tutorial, API, FAQ, and such. And here's just all the different kinds of visualizations that you can do. So, and it shows you here. So like, here's a cluster map. We can literally copy this whole thing, and we can just throw it in here. So let's add, and this is how you add a cell in here with the plus here. So we can just copy paste it here. And it is thinking, and it spits it out. So that's like, obviously this is not using our data. It's using whatever they're setting it to, but that's how you can just like, you can just take the examples and then, you know, you'll swap whatever variables, your data, and you can do it. You can apply to your own dashboard. So let's get it. And then there's another one, the scatter plot matrix. We'll look at this in a little bit. And again, here's like the code to do it. And all you have to do is like, you've copied this, and all you have to do, like for this one to change it, we'll change the data set here. Let me zoom in, everyone can see it. Like change the data set here, and then the hue species would actually work for our data set because that's one of our columns. But we'll see that in a little bit. So here, let's do a scatter plot feeding in our data set, our data frame. X-axis is going to be sepal length, y-axis is going to be sepal width, and then hue. So the coloring is going to be based on the species. So this is what we get. So here we can see sepal width, sepal length, and then our legend to show each one of the species here. So this is the relationship between the length and the width across different species. And so like, what can we like, what does this graph tell us? We can see like there's a little bit of clustering based on the species. So that can help us. Let's just say like we found a new, like we get a new row of data and it has not been classified yet. this can kind of help us to see like, oh, like we're not sure which species it is, but by doing charts, visualizations, analysis, it can help us classify to make sure that we're correct. So I added here, select the species clustering. We can see like, oh, this species is well separated from the others, have shorter sepal lengths, but wider sepal widths. Correlation, overlap. So yeah, this plot can help us understand the sepal characteristics of each species, showing potentially challenging in classifying versicolor and virginica based on these features alone. So that's an example of how we can apply what we learned so far in like a real world setting. Any questions on this? Yeah, this is how easy it is to just create a pretty scatter plot with. So SNS, this is the Seaborn library, as we renamed it to Seaborn, to SNS. And we could also put here Seaborn, and it would give us the same thing. And then, so box plot, a different type of visualization. So again, SNS.boxplot, fitting our data, x-axis species, y is petal length. So this is displaying the distribution of petal lengths for each species. And we can kind of see, like, there's very little variability for this species. So species differences, these are significantly shorter than other species. Since the box is compact, indicating very low variability. So the way you read a box plot is it gives you like the whole data set and then kind of like the distribution of it. So our mean is here, and then like how is the data distributed around the mean? And then this is the total. And then here's some of our like outliers are these little dots here. And I've included that. So like, yeah, both the versicolor and virginica groups have outliers. So data points represented by diamonds that are notably distant from the main clusters. And so this one like effectively illustrates how petal length can be distinguishing feature among the iris species, which is fundamental for tasks like classification in data science. So just kind of like having different types of visualizations would help us like classify which type of iris it is. Then we can do a joint plot. This is one of the, I think we looked at this on Monday. Again, SNS.joint plot. X-axis is the petal length, y-axis is the sepal length, fitting our data. And this is just setting the height and the hue, which sets the coloring. So displaying the relationship between the petal length and the sepal length for the species. So sepal length, petal length, combines the scatter plots and histograms with the kernel density estimates. So here we can see like the distribution per the species as well. And it gives like a little bit of a more comprehensive view of the dataset distributions. So like looking at the correlation between the lengths, species distinction, and again, like we can see like the clustering here, but then there's some kind of the blue ones, the setosas. Clear distinguishable. And then so the density estimates, the plots on top and right margins, they show like the distribution of the petal lengths and petal and sepal lengths. So we can see like, oh, setosa has a sharp peak at lower length, indicating uniformity in size. Versicolor and virginica have border distribution, suggesting more variation within these species. So setosa, this peak here, then these have a little bit wider. Then this is one thing. And so pair plot. Oh, what happened here? Oh, there we go. Okay. So pair plot. So this one just shows every single column with every single column, like what their relationship is. And so, for example, we can look at this chart right here, sepal length and petal length, sepal length, and then petal length. So we can see this chart is the same as this, except we don't have the coloring on here. So let's apply the coloring here. I'm just gonna comment that out, and then so we add the hue equals species. And now looking at this one, it's exactly as this one. So this one just gives us let me zoom out real quickly. So it just gives us the relationship with like each one of them. And the diagonal plots, these are the kernel density estimates for each feature of each species. Provide a visual representation of the distribution of each feature separated by species. So for instance, the Setosa tends to have a lower petal length and width compared to the other species. Off-diagonal scatter plots, these are the pairwise relationships. So yeah, we can look at correlations, differentiation, variability, and this one can help us like classify again the species. And the pair plot is a powerful tool for exploratory data analysis, revealing the nature of feature relationships across different classes and helping guide further analysis and model building. Very pretty. We'll do a break here, and then we'll get into stats, and then after that we'll go through another example, a little self-data project. So we'll do, let's see, what time is it? 8. So 7. Yep. One day I will be able to translate between the time zones. Okay. Yep, we'll do till 7:10. Okay. So let's get into, we'll do a little bit of some statistics. And I'm just going to show you guys what we can kind of do here. And if you're not, if you've never taken like statistics class or like an advanced math class, like don't worry. Like we're just gonna go through this and ask questions. I'm just showing you guys what the SciPy .stat. So this is the library that we're going to be using, and we're going to be importing it as stats. And so, for example, here we could do like look at the mean and standard deviation, and this is like what we saw earlier. Like we can do it with pandas as well, looking at like just like with the data frame doing the df.describe. Oh well, this is well, this is what we're actually doing. So we get mean, standard deviation, and then we can print it here. And here also a little bit of review from like the very first class of like string formatting. So this is how we can pass it in here. So like mean is our variable, then we do the f and our double quotes, which they could also be single quotes, mean equals mean, and that way we can print it out in here. And we can even add something here afterwards. Mean of petal width. And now it's in the middle here. And same thing, what we could see here. df.describe. We see, so petal width, 1.228, and then the standard deviation, 1.7027. So matching up. Good. Then something, okay, if you've done statistics, you might have heard something called t-test. So the statistics is a type of interferential statistic used to determine if there's a significant difference between means of two groups. So we're trying to see if like this like statistically significant difference. So the main purpose of a t-test is to assess whether the means of two groups are statistically different from each other. Commonly used in hypothesis testing. So calculations and output, the t-test produces a t-statistic, which is the ratio of the departure of the estimated value of the parameter from its hypothesized value to its standard error. And the formula and calculation depend on the type of t-test being performed. And then the result, we get p-value. So we get the t-test, well, the t-stat, and then we get the p-value. And the p-value helps us determine whether or not it is statistically or significantly different, statistically different. The commonly used threshold is 0.05. And I don't know where that came from. Somebody just decided on that, and that's what we've been using. T-test is widely used in research for hypothesis testing, such as medicine, psychology, social sciences, natural sciences, analyzing experimental data. So we can make the decisions about the hypothesis, determining if a treatment effect is statistically significant or differences observed in groups are likely due to a change. So in summary, fundamental tool in statistics to compare averages, testing theories, and making decisions based on sample data. So to perform a t-test, to see if there's a statistical difference between petal lengths between two species. So here we're going to do Setosa is one of the species. We have versicolor. So we're selecting here from the data set only species, only rows that the species equals to Setosa. And then we're going to select the column petal length. So here first, we're filtering out everything else, and then we're going to select the whole column for it. Same thing here for versicolor. Species include versicolor petal length. And here we're going to do, so tstat comma p-value equals stats. So that's what we imported our library as. SciPy.stats as stats. So stats dot t-test underscore int, and then we're going to pass in our two data sets. And this is the reason we can do it like this, where we do tstat and comma pstat, is because this one spits out those two values. So we could do, if we just did this, oh, I'll run this one first. So we can see here like what this outputs, test result, our statistic, and then our p-value right here. And then this one also, but we only care about these ones right here. So it's like, it's a tuple of 3 values, and we can assign the first two to the first two values of it. And then we can, after we've assigned them, so tstat, negative 18.9, p-value, 1.8036. And so if the p-value is below 0.05, we can say there is a significant difference. And like when we initially look at this, it looks like it's 1.8, but here, so we have E minus 34. So that just means there's actually 34 zeros in front here. So this is like a very, very small value. So we could determine that there is, so if we were to look at, so let's look at, we can look at right here. So setosa. So these are the values of the petal length for setosa. You see lateral 1.4, 1.6, 1.9, 3.78, 1.5, versus if we look at versicolor. So we can see that there is like a significant difference between these two data sets. Almost all of these are over 4. There's some 3.9, 3.7, 3.6. And I think we could do, can I do this only on this one? Yeah, so versicolor.describe. So same thing as we did earlier on the data frame. It gives us count, mean, standard deviation, whatnot. So we can see like the minimum here is 3, maximum is 5.1. And let's look at setosa, describe. And here we can see minimum is 1, max is 3.7. So, and again, mean 4.1, 1.7. So like there's a significant difference between these two. And that's something that the t-test can help us evaluate, which we don't really need the t-test to evaluate this data set because it's not humongous and we can simply look at these. But if it was like, if we're talking about like a clinical study on a medicine placebo, like control group with placebo and then the actual medicine, it might be less significant. And that's something that you could like apply a t-test for. Any questions on this? And this might be a lot because stats. Honestly, I took stats in college and not my favorite class, but very important when it comes to data science and drawing important insights. But I do find it like it's a lot. It can be a lot. Any questions? And even if you guys have just like questions on the code, in case I didn't explain it, because I might just, you know, just kind of glance through it at some points, just let me know. Then we can also do a correlation coefficient, statistical measure that describes the size and direction of a relationship between two or more variables. So if we're looking at the correlation coefficient between the sepal length and the petal length, and so this is for all the species. Yep. And then we get 0.78. And this is just the, like it says, statistical measure to draw more conclusions. So that's what the SciPy, I think it's SciPy, probably, library can help you do different kinds of statistical tests. And there's a lot of other stuff. And maybe we'll get into that later. Then let's talk a little bit about machine learning. I think everyone's at this point heard about, AI taking over a little bit. We have ChatGPT, Google. I think they call it Gemini now. It used to be called Bard, which I thought was a terrible name. So I'm glad they rebranded. And then there's Claude and whatnot. There's a new AI chat for everything. And machine learning is kind of like how those come to be. Those models are trained on certain data, and then you can ask questions on it. So like, for example, like ChatGPT, I think they fed a bunch of books to it at first. And that's kind of how they like the versions, like, oh, like we've fed like all the information on these books. So now it can answer questions based on those books. And then they fed more books to it. And then I think Google, since Gemini has access to like that one specifically, maybe like goes through web and stuff. So that has been fed into it. And then some of them, I think nowadays you can do like, I saw one earlier today. It was like an author, I don't remember what he thought, but like he fed all of his books and like videos to the model. And then he would ask questions and see how accurately would that model respond in comparison, like what he would say. So I think we're going to be seeing that a lot in the future. It's quite interesting and potentially scary. So for machine learning, sklearn is a big library that uses it. We can use for it. And so what's happening here, I think at some point, maybe we did this example. So when we do from sklearn linear model, import logistic regression, sklearn model selection, import train test split, sklearn metrics, import accuracy score. So this is like, if we just want like specific parts of those libraries, we don't want to, like, again, like if we know we only want to use these 3 parts of the library, we don't want to like import the whole thing, which this one technically is doing. But that one, it's more efficient to only pick out the things that you're going to use versus just bringing the whole thing. It's going to help your code run faster, and just overall, it's better. So we're cherry picking logistic regression, train test split, and accuracy score from this sklearn library. So what we're going to do here is we're going to create a model that would predict what species the record is based on, the sepal and petal sizes. So kind of like what we were looking at earlier with the visualizations. Looking at the visualizations and like where the cluster is, that can help us characterize which species it is. But we can also use machine learning for it. So what we're going to do here, so we're going to go back to the original data set before like we messed with it, did like the whole added null values or like dropped values. So just make sure here, so iris head, and then here technically we're overriding our previous data frame, but that's fine. And again here the columns. So let's see which is checking. So each column, the number of null values is 0. So that's good. That's what we want. That's the original data set. What we're going to do, so preparing the data, we're going to drop the species column from our X set, and then we're going to set Y to be only that column. So basically, X is going to be all the columns without the species name. So that's technically the answer. And then Y is going to be the answer. So what our model is going to be doing is going to look at the other 4 columns, trying to determine what the species should be. So we don't want to like give it the answer. So split the data into training and testing sets. Here we're doing, so the train test split, test size is going to be 30. So 30% of our test, like of the sets, is going to go to the testing, and then the rest 70% is going to be for the training. So this train test split, it's going to spit out X train, so X training, X testing, Y train, Y test. And here we can look at, oh, let me run this one first. So let's look at the shape of our X train is 105 rows, and then X test is 45. So 30% and then 70%. And if we were to change this, like we can do 25, this is going to adjust and change. And this one, like when I first started, I was like, what is going on here? Like it gets a little bit confusing, but it's usually, this is how it goes. So once you get used to it, it gets easier for sure. And again, we can look at this. We were to look at just this. So this is, it spits out here first. So let me do this again. So 105. So this is the first set, and then the second one. So that's what we're just, and then here's our Y values. Y train, Y test. Oops, did I just get rid of everything? Did not mean to do that. Undo. There we go. Yep, here we go. Yep. I'm just going to. So to train the logistics regression model, so model equals logistics regression. There's different kinds. What we're going to do is model.fit X train and Y train. So we're passing in our training sets in here. So this is training our model. So based on this, it's learning kind of like the characteristics of each species. So that's our model. And then our Y predict, let me actually split these into different, oops. We'll put in here, and then this in here, which it doesn't, I think. Oh yeah. So output is logistic regression. There's really nothing to see. Y-pred, yeah. So Y-pred is like what it's predicting it to be after, like with the model. So what the guess is in a sense. Model.predict, X test. So that's our testing data. And then we can calculate the accuracy score. So we're comparing the original and then our predicted values. So our Y test and then our Y predict, and then we'll get an accuracy score. So 95% accuracy. It was able to predict what kind of species it is based on our model, like that we trained. Any questions on this? It probably a lot. I'm just showing you what we can do with this. And maybe we'll do more examples on this later. But that's just like an example of like how a machine learning model is trained. And I know there's a lot of going on and there's a lot of words. So don't stress about it too much. Only thing, just be like, wow, that's really cool that we can do that, because it is. But yeah, any questions on this? And I know this doesn't like, I feel like initially you would be like, oh, like I want to see it. And technically I think we can take a look. So like what, Fred? So this one is, let's see how we can. So this is kind of like, that's the answer key. And then this one is, because it's comparing them here. But then, yeah, it's like a little hard to see. The last thing is Setosa, first thing is versicolor. Yeah. Okay, so yeah, that's what we can do with the sklearn as far as machine learning goes. But that's like, do you think that's like a little bit more advanced? I think if you're like a data scientist, this is probably something that they would expect you to understand. But for like BI analyst, probably not, unless you get into like a higher, more experienced role. Okay, let's go to, we're gonna go a little sales project, and this is in, let's see, this is in the shared drive here. The sales project notebook, and then the sales data sample. These are the two files that this one uses. And then what we previously went over is this Python cheat sheet, this one. So if you want to follow along, oh, this is what I did want to show. And I think we did go this over at some point, but like to open these notebooks, you can either upload them here, like upload here, and then we get it here. Let's just shut down everything that I have going on. Shut down, close everything. That's fine. Now we have the notebook here, but we also want to upload like the data set here so I can find it. Let's see if this works properly. Oh, thinking. Yep, there you go. So that's how you can follow along with this one. Or if you have your Jupyter notebook locally, you can open it wherever you have it in your folders. And that's just kind of what I prefer to use. So, yeah, so just gonna go a little bit of similar stuff. Gonna get a new data set, do some cleaning, and then do some visualizations on this. And so first we're gonna import some of the libraries. We have our pandas, matplotlib, seaborn, and then came across this fancy thing, plotly.express. I'd actually never used this, but it can do some cool things. So I'll show you that at the end. And that's a great example of not being aware of all the libraries there, is because I've heard of Plotly, but I didn't know there was an Express. And apparently Express just makes it easier. It's just like a little more straightforward, less work when you're creating visualizations. Yep, load and read dataset. So yeah, our CSV file path, and then we're gonna do our pandas data frame, read CSV, pd.read CSV, and then look at our df. Actually, we're gonna look at the head. So what do we have here? Which we're already doing this one. Jump ahead myself always. So we have some order number, quantity ordered, price each, order line number, sales, order date, status, quarter ID, month ID, year ID, product line, product code, description, customer name, city, state, postal code, country. So what this is, it is sales data on like model cars, like little model cars, like toy shops or whatnot. And it's not real. It was real, but then I messed around with it and made it not real. So if it doesn't make sense at times, that's because it is. it's not, it doesn't. Look at the shape. So we have 99 rows, 18 columns. And then we can look at the information. So df.dtypes, order number is a number, quantity ordered number, price each is a decimal, order line number integer, sales decimal, order date. Okay, so here we notice order date is an object. We'd probably want that to be date time object if we want to do any type of analysis over time, monthly, daily, yearly. Status object, quarter month ID, integers, part line code, whatnot. These look fine. And same thing, we have the .info, which pretty much gives us the same information for our dtypes. Then it also gives us the non-null count. So we can see all of these no null values. Then we see we have a lot of null values in the state, some null values in the postal code. So we can look at, so null values, how many, so what we're doing here is how many rows have null values, looking at the shape of it. So 54 rows, which makes sense if we're looking at the difference there. We can take a look at a couple of them. Since there's so many, I don't want to look at the whole thing because it's just gonna make a scroll. As we saw here, it's in state, postal code. We see the country's France, so we don't have state there, which probably has, maybe they have states in France, not sure, but not the same way that we have in the US for the way this is recording things. We're missing some postal codes, which that can be problematic, especially since I don't think we have, there's no like, you can't look up the address. So potentially problem. And this one just shows us. So here is null. df.null is null any axis. So this one's looking at the columns. And when we look at one, that one just looks at the rows. So everyone else has no null values except state and postal code. Okay, so let's convert our order date to a date time so we can do a little bit of analysis over time, look at monthly trends and whatnot. So df order date with a column, pd dot to date and time, to date time. So again, this is from the pandas library, passing in our column, and then this is the format that it's currently in, which we can see here. Order date is month, date, year, and we have the year is 22. So, and this is, there's a way to look at like how the pattern works here, but that's how we would put it for. And then we can look at df.d types to confirm date time. Any questions so far? And this is all we've seen all of this before, just doing a little bit of review. But yeah, if you have any questions on this stuff, just ask or drop a comment in the chat. Okay, so again, we saw earlier we have null values in state and postal code. So for now, let's just, says postal code, technically this is an object, so it's just a string, it's not even, which we could convert that to an integer after we do this. So df.fillNA, so again, our data frame, fill the null values. And this is how you can set it to like only like if you wanted specific columns only, we can pass it in. So this is a dictionary here. We have our key and then value. So all the null values in postal code, turn that into 0. And we could put something else in here. And we could have multiple, let's say if there were null values in country, we would add it in here, country, and then null, like empty value or unknown. But we don't have any, so we don't need that. And then we do the in place, which means it modifies the original one. And then after we fill in the postal code with zeros, we'll do fill all null values with empty string, which since we only had null values in the state and the postal code, like only the state is gonna get filled in with null values. And we could have also done this way, the state, and then here. But since we don't have null values in any other column, we don't have to specify that. So let's look at df. Dped, which actually that's not going to show us. What do we? Let's look at here again. Confirming. Okay. So no column has null values, and that's what we want. That's good. Then we could do our drop duplicates. df.drop duplicates in place true. And what was our, let's see, our original shape was 99 and then 18. Let's see, take a look at it again. Shape. Okay, we had no duplicates in the data set, so that's good. And we could look at it, let's see, look at df, what do we have in here actually? What are the columns? We don't have like a, yeah. There's no like unique ID or anything like that as far as like the customers go. We do have order number, but those most likely all different. So that's good. No duplicates. Yeah, so we can add, oops. And here's an interesting thing that you see. If you just do dot head, it's gonna like spit out this instead of if we did head and then this, it's gonna give us the tabular format. Why that is, I don't know. But here we can see we have zeros. Let's look at bigger head here. 10. So we have a couple of zeros here, and then these are just empty for the state after we filled in with the nulls. All right, filled the nulls in, yeah. We're look at the shape, yeah. All right, so we could do break right here, and then we'll get into the data analysis, and then at the end we'll do the visualizations. I think that will be a good break point. So we'll just do 10 minutes. Anyone have any questions so far before we take a break? And this is kind of what we did with the data cleanup class and those notebooks. Same stuff, just converting data types, filling in nulls. The same thing we saw last class we did that little example. But yeah, we'll take a quick, yeah, we'll take 10 minutes right here. So 8:55. No, not 8:55, 7:55. Is that right? Yeah. Yeah, that's right. Okay. Okay. Make sure this is working. Yep. Okay, cool. Okay, so let's do some data analysis on this data set. So to calculate the total sales per product, we have total sales per product. We're going to do df data frame dot group by, group by product description, and then get the sales column sum. Then this is not really necessarily like sorting values, but just to sort them descending. So this is probably like very similar to like what you would do in SQL, doing a group by and then a sum. Probably not the exact order of things, but same thing in SQL. You will group by something, and then that's how you can get the total sales per product. Same thing, you can sort there. Sorting this, and then what this one does. So we're printing total sales per product, and for a for loop, so we have product, comma sales in total sales per product dot items. So total sales per product is a dictionary, and to access like the key value pairs, we're gonna call dot items, and that way we get the product, which is like the key, and then sales is the second. But I think this is, I don't know if it's a, might be just series, but anyways, that's how we get like the item pairing is product and then the sales. And then, so for each product, we're going to print out product column, our dollar sign, sales, and then here we're formatting the sales to two decimals here. And that's how you like format it. And I think this is just like, it means 2 decimal float. I think that's where the F comes from. But yeah, so for each product, we're in the loop, we're going to print it. So here we see, and then with the sorting values, we see that this 1954 Corvette convertible, the total sales, 991,000. We have Maisto Audi R8, 131, Mercedes-Benz 106, and then Porsche 911, 97,000. And then we can also do, so total sales per country, again, data frame dot group by country, the sales column, getting a sum, and again, we're sorting this. We do the same thing here. So product is sales, and total sales per country dot items, print out. So we see total sales per country, USA, 266, France 96, Finland 71, Norway 63, and Spain 26,000. Any questions on this? And here we can see a little bit of just like regular Python syntax, just how you would apply it to non-data analytics or data science with the for loop. For loops are very, very common. Any questions on this? We can also get the best-selling product per country. And here we have a little bit. This one's just sorted. Yeah, this one could technically be all in one, but sometimes it can help to like break things to their own variables. Sometimes it makes sense, sometimes it doesn't. So country, product sales, df.group by country, and product description. So as we're looking at per product and per country, sales, sum, and then reset index that just gets resets the index. And then the second one just sorts the values by first country and then second sales. The first one is ascending, the second one is not. The second one is descending. And then this one, drop duplicates. And again, we're going to do a for loop to print this out. For index, row, and bestsellers, country.iter rows. Print for each row the country, and then the product description, and then the sales here. So we get best-selling product per country. And then we have the Maisto Audi R8, total sales, France, 1954 Corvette, 34. Norway, Porsche 911, 23,000. Spain, also the Corvette, and the USA, also the Corvette, 19,000 and 94,000. And then lastly, we can look at some monthly sales trends. So monthly sales equals data frame dot resample based on month on order date. So we're sampling from the order date, getting it per month. And then we're going to get sales and then sum, and then print monthly sales. So here we can see that, so this is like the last of each month. So first, January, February, March, April, so on. And then again, we get it for so 2003, 2004, 2005. And these are the full sales. And again, we could have printed this, formatted it a little bit prettier. This is just how this spit it out. Okay, so we did some calculations here. So let's do some visualizations. I was looking at last class, we talked about a little bit of the styles. So here's the Matplotlib style, ggplot, and then SNS set style WetGrid. Those are the two that I found that still not the crazy pretty, but you know, they'll do. Okay, so let's do a bar chart for total sales per product. We're going to do total sales per product dot plot. Kind is bar. Our title is going to be total sales per product. Our X label is going to be a product code. The PLT, the Y label, total sales. And then for the labels, we're going to rotate them 45 degrees. So here, these are rotated 45 degrees, just to make it easier to read. Okay, we have it as a bar chart. We can see, which one is this? Total sales per product. Yeah, so most sales on a Corvette, Maisto Audi, Mercedes-Benz. And this one we could, if we don't do anything, it's gonna do it this way. And then we can also do Hindi. No, actually, I think because it's so long, the default is horizontal. But I think it's gotten smarter actually. Back in the day, I think it would just like overlap each other. And that would be no good. That's what we have. Very nice plot. So product code. Oh, this one could be product description actually. Product, maybe just product. Yeah, total sales. We can look at our monthly sales trends. Our monthly sales. And so this is where, just to make this clear, so the total sales per product, this variable came from here. We calculated it earlier. Total sales per product. So we're just going to use the data from that. The same thing, the monthly sales. We're going to do monthly sales. This one was over here. Monthly sales equals DF for example. So monthly sales dot plot kind is going to be line, title monthly sales trends, X label is month, Y label is sales. And this is no longer required. You used to have to do like the plt.show. I think you don't need it at all anymore. Yeah. Versus, and then I think some of them need this, that whole thing. Let's see if that one could disappear from there. But you used to have to put like plt.show to get the chart to show. So that's kind of a like example of what we were talking about earlier. Like when they release new Python versions or when they release new package versions, they change things and then things might not be compatible anymore. And let's just say you've created a project on Python 3.7 and then your boss opens it on their computer and that they're running. Usually it's compatible when you go from older to newer. Not always, because sometimes things are deprecated, but oftentimes it just gives you a warning. But so let's say that other way. You're using 3.12 and then you send it to your boss and they only have 3.7. They're probably going to get like a lot of errors because the versions are not compatible anymore. And there's ways to like get around with that. I think you could like Docker is I don't even know how to explain Docker. It kind of just like creates an environment for you that imitates what was going on. And then if you can send like that environment or like they can open it. They actually call it a Docker image, but basically like if they were to open that image, it would assimilate the exact same environment that you were using because that's what you set it to. And if you don't understand what that means, it's fine. It's not that relevant. But just saying, there are ways to like handle version issues. Any questions on these two plots? And here we can like, if we were to look at some insights on this. So October, end of the year. So this one we could basically see that this is like around Christmas. So October, November, December have the highest sales, both 2003 and 2004. So that makes a lot of sense because most toys are bought around that time. So that's kind of like one insight to look at it. And then we can look at like, oh, very little sales around May, June. And then same thing here, April, just a little bit. So this is kind of interesting because here between April and July, very low sales in 2003, but April and July much higher. So like if we were to run, like you're running this business and you're trying to figure out like, hey, how can we do better next year? So for example, it's probably like why Amazon implemented like Prime Days, which happens in July like 13th or something like that. So like they probably have like the lowest sales around then because there's not a whole lot happening and you're about to, well, some people are starting to get ready for like school season or whatever, but there's no Christmas or anything like that. So they make Prime Days, so now they can get lots of sales. So this is probably what happened here is they're like, oh, we have terrible sales. So next year, let's do like a sales event in May, June to up them for the next year. And here we can see we only have data up till here, but this is even higher in 2005. So whatever was done is working. That's one example of how we would use our insights. Then we can also look at, so quarterly sales, group by year. So year and quarter sales sum again. Getting a matplotlib figure using Seaborn bar plot. So again, this is just a different way to do a bar plot. And we saw that last time. You can use pandas, you can use Seaborn, you can use Matplotlib. So SNS.barplot X is going to be the quarter, Y is going to be sales, and hue, year. So this is the color and the legend. Data is going to be our quarterly sales. So this one, we're going to pass it in. Title, quarterly sales trends by year and quarter. X label is going to be quarter, Y label is going to be total sales, and then we're just going to include the legend in here. So here we can see each year per each quarter. And we don't have data here for quarter of which one is 2005. We only had until the first 2 quarters. But this is something we could again see, like 2004, nice quarter growth. But looking at like from 2003, what does that tell us? In comparison here, like 2003, not that great, quarter 1 sales. 2004, really great, but then it went down again. So something that was working in year 2004 no longer works in 2005. Or maybe they didn't do it anymore. But we can see 2004 was like the strongest year here until quarter 4. We don't have a full data set, so we don't know fully on 2005. Then we can do quarterly sales trends by country, year, and quarter. So country, quarterly sales, df.group by, country, year, quarter, sales, .sum. Again, we get it all figure, same thing as before, just different data. So this is, we're looking at, what is our, so this one's putting the years together, looking at by country. And we're missing this is interesting, no sales in Spain in quarter 1 or quarter 3. And then we have France, pretty nice growth over there. But again, this is like, we're looking at the years altogether. And the USA, strong quarter 2, very strong quarter 4, which explains Christmas. And then we also don't have Finland. Well, this is just madness, because if you guys didn't know, Santa's from Finland. So clearly nobody had to buy any toys because Santa delivered. Parents got off easy. So that's good. And I'm not even joking. You can go visit Santa if you ever go to Finland, go to Lapland to visit Santa. Great experience. Highly recommended. But if you don't like cold weather, still go. Or go during the summer. It's worth it. You can pay $30 to get a picture with Santa. Capitalism. Let's see. Country. What do we do here? Is it the same thing? Oh, this is by product. Okay. So this is per country. And then here we're doing this product quarterly sales. Not country. That's right. Yep. Product quarterly sales. Grouped by product description. Year ready, quarter ready, sales and sum, the same thing. X-axis quarter, yep, same thing. And then hue is going to be about product description, which means this one is the product. Here we go. So what can we see here? So Corvette outperforming quarter 4. Porsche, interestingly, very steady growth throughout the quarters. And yeah, we probably want to like break this up by a year, which isn't also wrong. Well, no, it is. It's not per year though, but it is grouped by, which doesn't make sense here necessarily. But this one maybe like make different graphs for each year to kind of look at it. Or we could potentially also do like a stacked bar chart or something like that. But yeah, lots of things you could do. All right, let's do, so our best-selling product, sales per country, which again, this one was bestsellers per country. And this is what we calculated here before. Bestsellers per country. So this is what it is. So we're just going to visualize it. I already set this one, so this one not really needed. Getting a figure again. So S and S bar plot, X is country, Y is sales, product, data is going to be bestsellers per country. And then best-selling product sales per country, country sales, same thing, rotation. Here we can see, so Corvette is the bestseller in France, Spain, and USA. Porsche is in Norway, and the Audi is in Finland. And then we can see the sales for each product. And something, this is, we have this additional argument here. It's called Dodge. And I actually had to look this up because, so like initially it looks like this, and that's because it's like expecting for each, like it's expecting more bars in here. So, and since we don't have, so what this Dodge does is it like fills it in, that it only focuses on the data that we have available. So it's no longer like funky. So there's a like, there's other, you know, a lot of other arguments that we can pass in here. And that's something that I didn't know. And all I did is like, hey, and that's just like, I think we talked about Stack Overflow really quickly, but what I did was like, oh, like Seaborn bar chart bars. I don't know what I Google here. Bar charts not properly aligned. So here we can see like Stack Overflow. That's kind of like the, and so here we see, and that's the thing, like a lot of times when you have a question, someone else probably had a question before you, and you can find it on Stack Overflow or somewhere else. And again, like we could use ChatGPT and be like, you can fill the, like, you can just give this specific data to ChatGPT and ask about it, and it should probably be able to. But like here we can see the exactly same issue. So these look a little funky. The A is all the way here, B is all in the middle, C is in the middle, but here. And this can be achieved by doing Dodge equals false. And if you're not familiar with Python or Seaborn, this might not be super clear, which I don't think this answer is, it's right, but it's not the best answer. So sometimes you have to kind of still go through. And this one was actually, this is a duplicate. So this is where you can have Dodge false, and here we can see Dodge false. So if you ever become like really good at Python and you want to start answering people's questions, offer proper examples, and people are more likely going to upload that. And this is even nice because they added the pictures here as well. But yeah, Stack Overflow is going to be your friend. ChatGPT is going to be your friend. And that's kind of very similar to like we discussed earlier is like about the libraries, like, oh, like how do I know like what's the best library to do XYZ? You're just gonna ask. There's people who are gonna tell you. A lot of people who've done these things way before us. A lot of smart people online. I saw somebody who was, I don't know where I saw this, but like they would want to make sure that they get like the correct answer like fast. And what they would do is like they would post a question on like Stack Overflow or Reddit or wherever, and then from their second account they would comment a wrong answer. And if anything, people love correcting other people versus like, you know, sometimes you're like, ah, like I don't want to answer this. But if you saw someone is gonna like say something that's incorrect, you're more likely to answer it. So very interesting technique to get proper answer quicker. Then we can do, let's see, market share per country per product in each country. And here we are again, we're gonna do a for loop, country group in tf.group by. Let's look at that real quickly, what this actually gives us. If it'll show us, no, it's not gonna show us. If we print this, I don't know if it still works actually. No, it doesn't. Disregard. Anyways, what we can access there is the country and the group. We're going to create a figure. Sales product is going to be group.group by product description sales sum. Group.group by product description sales sum dot plot, which this one should just be this thing. This thing. Yeah. Sales product dot plot. Go to pie chart, which may or may not be the best way to show this thing. Labels, sales per product, index, and then this one. Yeah, so this one's gonna give us the like the actual number of the percentage. And this is going to be the formatting of the percentage, or like the label. Title is going to be market share in country. PLT Y label is just going to be nothing. So here we can see market share in Finland. We see 32% Corvette, 44 is the Audi. Porsche doesn't sell very well there. Interesting. 19.7 for Mercedes-Benz. And then we have France, Norway, Spain, and USA. And that's what it did. So it went through each one of the countries and it created its own figure. But this isn't very easy to see, is it now? So what we can do, if you guys recall one of the notebooks that we were going over here in data visualization, customize plots, we could do like these different layouts, the subplot mosaic. So let's do that. We're going to do a figure and axis, plt.subplot mosaic. And this one is defining, and we could do this the same way as here. It was like AACD. But what you need to make sure is that like you have same amount of columns in each row. So like initially, because we only have 5 countries, so like the initial idea could be doing this and then doing like A, B, C, D, and then doing E. But this one's going to give you an error because we don't have the same amount of columns in each row. But this one could be like literally like nothing. So that's what we're doing here. So it's an empty thing. And then we're going to do a for loop again. So for country, group, in df group. And we're going to use a counter to fill in each one of these. So we only have, which we could say like set it to be 5 because we know it's 5, but to make it more dynamic, we're setting a variable for it. but here it is like if countries plotted is greater than the axis, the length of the axis, so the number of axes. So here, technically this will be 6. So that's when we're gonna break. So we don't want to like plot more countries than there are placeholders in our figure. And that's what this is doing. And break just means it's gonna break out of this for loop and just stop it. Any questions on that? And what we're gonna do here, so the ax equals axis from the keys, a list of the keys, countries plotted, which is the, like that's gonna be the index of what we're looking at. So it's gonna go through the keys and then just get the index here to like figure out which axis it's gonna put it in. Sales for product, group by product description and sales. Sales per product dot plot. We're gonna do a pie chart. So this is we're doing the same visualizations here. We're just gonna make them prettier, or like not the actual pie charts prettier, but like just put them on a dashboard kind of thing. Labels gonna be the same thing, same formatting, and then ax is gonna be ax. Setting the title, market share in country. So from here, we're gonna do country name, set in the title. We get rid of the Y label, it's not important. Then I'm gonna increase the countries plotted. And this one's important. We discussed like for loops. You wanna be careful that you don't create like endless loops that just like keep running forever. Like you could do like while true, but if you never have a break in there, it's just gonna keep running forever. So if we didn't have this here, the countries plotted would never get increased and we would never hit this break statement here. And I think that's very easy to forget a lot of times. I definitely often, because like if you're not using a for loop with an index already, that could be, you might forget about that. And then this one just, since we have only 5 like charts or pie charts, this one just gets rid of this empty one, and it's really not that important. It will be like an empty chart here, but it just gets rid of it because there's nothing. But here this looks a little better. We can like, and if we were to like, we could export this as a PDF and like look at it on its own. So now we can kind of see them. And here we can see Spain only sells these 2 types. They don't like Porsche. I think it's Porsche. Is that the most proper way to say it? I think people like talk about that all the time. And I don't remember which one's right or wrong. So don't quote me. Anyone have a question? Nope. Ooh, chat.
I did notice something. So when you pointed out that Spain only has the 2 cars, there's a blue wedge, but it's labeled Porsche, and the other one's the Porsche is gray, and the Audi is blue. So why would that be different?
So the reason that's happening is because it's creating these like individually. So like every single one of these is like an individual graph. So they're not relying on each other. So that's like a great thing to point out, that this actually wouldn't be a great thing to like show to someone, because that would be confusing. I think they're like, you probably have to set the colors. Like what we could do is, for example, like in the data set, like you would add a column that is going to like, you put the color in it. And then that way you're going to like determine like what the color of the pie will be, or like the pie slice will be. And then that that's how you would get it consistent across. I don't know if there's a way to set it without having it like in the data set, since they're not dependent on each other. Every single one of them is its own thing.
Okay.
Yeah. But yeah, that's a good point out. Because someone would totally look at it. And probably, yeah, I mean, if you didn't read them properly. Because I think like how it works here is it has like the set of colors that it uses, and it's just gonna go them in an order. So it always starts out with red or blue, and then it's gonna go to purple, and then it's gonna go to the gray one. But since this one only has 2 variables, it only got through the first 2.
Yeah, that's kind of what I was thinking maybe happened, but it's interesting.
Sorry. This thing, I can't believe this is a thing, because I do it on accident all the time. And yeah, not a great.
We were celebrating because I figured something out. But
there you go, perfect. Yay. No, and then you can do thumbs up.
Sense that it kind of goes in order by like assigning colors, but yeah, that's interesting though.
Yeah. So yeah, I think that would probably like adding it in the data set to make it a constant. Or we could ask ChatGPT to how to do it, but it might be too complex. But I'll look at it and I'll let you know next time how to do it. What's a good way to do it? But yeah, this was just to show that how to use the mosaic thing if you wanted to. And this, what we could do, like instead of using the same, like using a pie chart for every single one of these, like we just like scratch the whole for loop, and we could like in A we'll put a bar chart, and then B we'll put a pie chart and line chart and whatever. But that's just how you can like put them, and that's what it was here. So like set title. I think, did we show how to add them here? I don't think so. Oh, this one. So for example, like, yeah, here's what color B, but that's not the same thing. Yeah. Anyways, but oh, where'd it go? So axe, let's see. So this is how it picks it. The axe. So we would do like axe equals axis A, and that's how we could set it. So we would have like, we want to rename this something else to like be specific for that AX. So we could like axe underscore A, and then pick the A, and then axe underscore A set title, and so on. And that's how you can like put the different charts in there instead of using a for loop. Oh, and this one was so this is for the Plotly Express. So that one was, we imported that as PX. So Plotly Express as PX. We're doing the same thing here actually. Full country product sales, group by country, product description, sales. So the same thing as we're doing the market share here. So figure equals px.treemap, passing in our full country product sales. Path is going to be country and product description. Values, the sales. Color is going to be sales. Color continuous scale. This one's just like red and blue. Title, market share per country in each country. And this is actually like really, oh, and yeah, this one. So this one we actually do have to do. We have to do show. Yeah. So I think it depends on some of the libraries, they'll just show it. Or is it if I don't assign this, it might just show it. Nope, that one you have to do show. Okay. But this one is actually dynamic, which is, I didn't know that. And I think this one is probably very similar to like what you can do in Tableau. You can do a tree map, and you can even click on these, which doesn't mean a whole lot with this data set. But, well, yeah, here we can look at Finland only. And we can see, so our Audi, sales sum, and the parent just, yeah, the parent means that. And then, yeah, there's probably a way to format these, whatever is in the tooltip. But yeah, so that's just another example with a different library that they do different kinds of visualizations. And I think this is really cool that you can, I haven't seen a dynamic or interactive visualizations previously. But yeah, that's a great, like, going back to what we talked about like in the very beginning is like, oh, well, what is the best library for interactive visualizations in Python? So there's Altair. I have not heard of that one. Let's see, 10top. So there's an example of top 10 Python libraries for data visualization. And this one even tells you how to use it. So importing packages, importing cleaning data, creating visualizations. And this is characterized interactivity, syntax, main strength, and use case. Oh, okay. There we can see our library. So Matplotlib, what we've been using, Seaborn. No, I've not heard of this one, and Plotly. So main strengths, highly customized plots. Seaborn is very fast and presentable reports. Bokeh, no idea how to say that, offers interactive visualization of big data sets. Altair, data exploration and interactive reports. Plotly, commercial applications and dashboards. And yeah, here we can see interactive features, limited, yes. Most popular libraries for data visualizations. Matplotlib, Plotly, Seaborn, ggplot, Altair, Bokeh, ByGal, GeoPlotlib, Folium, and Gleam. I haven't like even heard of some of these, but that's a great example of like there's just millions of libraries for any purpose. Here we can see Matplotlib, key features. I can paste that in if anyone's interested in looking at this. So like, yeah, pros and cons, not ideal for time series data, versatile library, learning curve, and compatible with NumPy arrays and Borders SkyPy stack. And tells you how to install it. Plotly, most popular data visualization library in Python. Readable for beginners, widely used for handling financial, geographical, statistical, and scientific data. Difficult to use, limited 3D plotting capabilities, heavier resource-intensive library. Allows 40 unique chart and plot types, offers contour plots, dimension charts, so on. There's a Seaborn. So yeah, this is you just like read and hear about new libraries, and that's how you learn about them. And then, you know, like Altair, like this one looks cool. So it could be something worth exploring, seeing what we can apply it. And we were looking at, I forget what the data set was that we had latitude and longitude on. So this one could be cool. Oh, this is interesting. So this one allows like scrolling things. That's very interesting. Yeah, so like if you're making like more like dashboard type of projects, so like similar to what you would do with Tableau, you'd probably want to use something like Bokeh or Altair or whatever, like actually, or Plotly, which allows like interaction within the dashboard versus just like static charts. But if you're just sending a report, then you probably don't need it. Because this one definitely would look a little silly on a PDF. Ooh, look at that. Build maps and plot geographical data. Very interesting. So yeah, there's something like that. All right, okay. Any questions on this? Any questions on anything? How are we feeling so far? This is our 4th class, which means we have 4 more to go. Next week, we're going to start talking about like a final project that you will be doing on your own. You'll get to pick your data set for it. But there's no rush. It won't be due like next week. So, but I'm just talking about it. What do you guys, is there something that you can think of that like you want to see more of? Something that would like help you complete a full project to doing this?
Well, can you tell us a little bit more about like what the project will be or like what we'll need to accomplish in it? That might help me know what I need to know more of.
Yeah, valid point. More like similar to this, like you're gonna be picking up a data set and then doing cleaning on it. Whatever we've been doing so far, and then like draw some insights, create some visualizations. It's like a little bit let's see where, like it's a little like not super restrictive. Like you get a little bit of a freedom on. So let's see.
So finding a data set, cleaning it up, and then using the data to make some visualizations.
Yep, pretty much. So selecting data set, loading, exploration, cleaning, validation, transformation, data analysis, insights and recommendations, visualizations or dashboard, and then like documentation presentation. And again, like you can choose how you want to do these, like whether it's just a notebook or you want to do a PDF or a full like PowerPoint or something. But yeah, it's very non-restrictive. Just similar to what we've been doing so far, but like you just do like the whole thing yourself.
Okay. I think I'll go back through the previous lessons to kind of be like, okay, here's all the functions for cleaning data, and here's the functions for like how to group data and make the data frames and stuff. I think just reviewing just sort of like the basic steps, or like here's how you do these typical functions, and just kind of get more familiar and confident with like, oh, here's how you structure this thing, and here's what these little like bits and pieces mean. And I think it's just refreshing and reviewing that. So
yeah. If you guys like think of anything over the weekend, or like, and this isn't like, you guys don't have to do this right now, or like even this week, and like we'll talk about it more next week. But yeah, you guys can just like drop in a Slack like, hey, like, can we do an example of this, or like, can we go over this again? And I can incorporate that into the lesson, making sure that you guys feel comfortable. That you wanted to see that you haven't seen so far, or there was a topic that we've touched on very lightly and you want to learn more about, like let me know and I can make some adjustments and add some stuff in.
Okay. This is kind of off topic, but is like Jupyter Notebooks or something similar, like embeddable? Like if I were to make a portfolio and have some of these, especially I saw that one that where you had like you could move the slider or something.
Mm-hmm.
Those things embeddable. I don't know if I present it for our project, but just kind of thinking ahead.
I think what you would want to do is like instead of like embedding a Jupyter notebook, you'd probably just like want to embed the Python code. Because like you can embed Python code in like a website. I'm like pretty positive on that. So instead of like you embedding the, and I feel like there's a way. I'm not like 100% sure, and I can look that up and I can tell you next time how to do that.
Or is there like on Tableau, you have kind of a profile that you can link to and it shows all of your projects that you save in there? Is there something like that?
What you can do is you can showcase like in your GitHub is like I have my GitHub, let's see, which you can even do like a personal website here. So like here, which is not going to show like a ton, but like here you can see like my popular repositories. I like here's the script that I showed you guys in the very first class, and like people can go see like, oh, okay, like this is all the code that she's created here. So, and this again, like for version control purposes, you'd want to do this, but this is like for like as a software engineer, it's like recommended to have your GitHub on your resume, so like employers can go look like, oh, like what does your project look like? And like here is for example, here's a project that I work on through school, and this is like a whole like website. So they have a link to show the whole thing, and that's kind of like that could be one way to like showcase it, is like, oh, like here's my Python notebook or like my Python code, and then you can like embed the visualizations on your website or whatever, and it's like, hey, like to look at the dashboard, like go here. But I'll look into like I want to say you can embed a notebook. Yeah.
Okay. Probably. I'm gonna try to get the local versions and stuff, and maybe I can dig through it and see what makes the most sense. But I was just trying to figure out the best way to like share what I can do or what I've done into like a portfolio. So yeah, I can kind of see, but okay.
Yeah, I'm sure there's like just like looking, it's like, oh, best ways, and I'll look into this. Best ways to showcase your
I was just thinking some of these ones we're kind of focusing on.
Yeah, I think technically you can have like, I can send you this notebook and it will have everything already shown or whatnot. But the thingy often is like people want to run, like you want to run the code, and then like in order for people to run it on their side, like they have to have the libraries installed. So that's like the thing. If you want it embedded somewhere, you'd have to make sure that it's
all the
packages follow.
Like, here's the code, and then here's what it looks like in the end. Like,
yeah,
not making necessarily for them to run it, but just like just to basically display it.
Yeah, that's definitely like with GitHub. And with GitHub, you can actually like create a personal website. Like you can have a repository that is a website, and then you can make that your profile page, which is one of the projects that's on my list to do. Have not gotten around that. But instead of like having to get a domain or like use like Wix or whatever, like whatever, that's like one way. So yeah, and most people in tech are very familiar with GitHub. So
GitHub intimidates me a little bit. Like I've used it, but then it's just like you click a folder and then there's like 100 folders. I'm like, I don't like it. It's not good for my neurodiverse brain. But like,
yeah,
I
yeah,
have a portfolio website already for like my design work. So I was like, okay, well, I could maybe like, so
yeah,
there's lots of ways to do it. I just was, as we were using this, like what was maybe possible with it. But
yeah.
we need to get better at GitHub, and I will eventually. It's just not something I just had to
I think
enough to
I
care.
I think just like don't even worry about like GitHub, but like worry about version control, because that's like it's just like so important and so helpful. Like there's so many times that like like I'm working on some project, and then like I'll save it and whatever, and then publish my changes, and then I'll come the next day and then I'll mess up something, and then I'm just like, well, this worked yesterday, why doesn't it work anymore? So then I can just you just reverse what you did today. So highly recommend. And we can talk, like we can go over, like I know we went over how to do the commits and whatnot very quickly, and like we can go that over again. And we'll do that for before you guys start on the project, because that would probably be really helpful.
Yeah, maybe kind of before we are kind of, I mean, we're not going to be on our own, we'll have class, but like maybe just like sort of just kind of a recap of like, here's sort of like the order of steps. Cause I still am kind of like unsure, even like, I realized I could put the code into a notebook, but then I'm, like even like I'm realizing you save it as an IPYNB file. Like, I would save like an HTML file or a PHP file, like just kind of going through, here's how you save the file, or here's maybe how you do a little version control. I think that would be helpful.
Okay.
Just so I can learn, like just to learn like the project, or even just like a tiny project from start to finish, just to understand like the checkpoints or the steps in that.
Okay.
Does that make sense, or would that be okay?
No, yeah, we can definitely do that. I think, because like the thing is, and I think this happens a lot with people who, it's so hard to like revert back to like, oh, when I didn't know anything about this, like what did I want to know?
Yeah.
Because like you say, I'm like, oh, like how to save it or whatever. The thing, like, I don't even think about it because it autosaves.
Sure.
And like, so like things like that. So it's very valid. And then here it would, you can upload and download or whatever. But yeah, I can do that. We can do that before the project.
Okay. Yeah, I was like, as I'm looking at it now, I'm like, okay, I see it's like similar to other like code editors I've used, but it's just kind of like, okay, I just want to make sure like I don't do it, and then it's like, well, where did it go? Because it didn't save or whatever, and
Yeah, no, Jupyter autosaves, and it even shows you like if I do something, it'll show like unsaved changes, but then a few seconds later, it's gonna be like, oh, all changes saved. I was gonna say something. But yeah, the only difference like with Jupyter notebooks or notebooks in general in comparison, like just coding and Visual Studio, is that this one, it's the blocks. Like it only looks at this block at once, and it doesn't have to like run the whole code. You could do this code in, now you can see it says autosaved.
Yeah.
And it's it right here. But like I don't really use Jupyter like I use Jupyter notebooks when I'm like debugging something, because I don't want it to like reload the data every single time and whatever, because like it saves the variables and whatnot. But like whenever I'm coding in Python in general, like I just use Visual Studio. But the only thing is like you can just do kind of step by step, and you can worry about like this block of the code at a time, and that's more or less like the difference.
Yeah. I wonder if I have two things. So first, I think I know, but I just want to verify. So when we uploaded into the folder the sales data project that we were just doing, and then the CSV, and then you put in to import it just because it's in the same folder, that's how it knows where to find the data. Is that?
Yeah. Yep.
Okay.
So
that was my question of how to like attach the data.
Yep. So if this data wasn't in the same folder, you would have to include like the full path to it.
Okay, gotcha.
Or if it was in another subdirectory, and this works the same way in like Visual Studio. So like if you have something in a different folder, you just do like the relative path, and you can also do that here.
Okay. Yeah. So that made sense. I was just double checking.
Yep.
And I was wondering, like, yeah, maybe like before we kind of start our own project, maybe doing a really, really small, just like all those steps. It's like, okay, like, because and that we actually type in the code like along with you or something, because like for now we're like seeing it and we can do shift enter and we see how it works. But I think for me at least, and I don't want to speak for anybody, like typing in the code helps learn it. So maybe even if it's like the simplest little like data set and like little things that we're doing is like, okay, here's our little data set and we're going to like upload it and then we're going to import this library and then we're going to clean it. And like we type in the code and do it. I think for me, that would make me feel like, oh, okay, I'm doing it now. And not just like I'm watching you. I'm like, yeah, this makes sense. But then I'm like, I don't really remember everything. So that might be really helpful to get people like comfortable to go do that process on their own. I don't know.
Did that, I know this one didn't have visualization, but like the data cleaning notebook that we did, like this one I left like the empty.
Yeah.
So like similar thing, but we'll just do like include visualizations and stuff.
Yeah, maybe. Yeah. If there's just, even if it's just so simple, just the process of typing in the lines of code, I think
okay
would be really helpful. I mean, for me, I think it will be, and maybe
it's
that's too
for
tedious,
like,
but
no. As far as like, I think like the guidelines or the instructions, like what level do you think would be like the helpful? Like, do you just like want me to say like, oh, like upload the data set or like,
yeah, I think if, I mean, yeah,
or like do you like, should I say like, oh, import the pandas library and then it has an empty cell, or just saying like, oh, like import the libraries you need or whatever, or not even say that?
I know this sounds kind of silly and maybe it is just too much, and maybe I'm just like, I really, really like it broken down, and maybe I'm not smart enough.
No.
You could almost do like, okay, first we are gonna like import the pandas library because pandas is really good at like the data frames or whatever. I don't know. So you'll type in, and you could even have the line import pandas as PD, and then we just retype it. I know that probably is so oversimplified. And those things are maybe a little like, maybe we don't have to do all that. But with some of the code, like we were kind of getting into the accesses, and it kind of had a lot of little components. And it was like just practicing, this is the order they go in, this refers to this. Like when you write, you identify your variable, then the variable goes in the next, it's like just really like practicing that. And maybe I'm over granularizing it. I don't know. But
listen, it's a lot. There's a lot of things happening. Yeah. So we'll make it work. Okay. We'll get through it.
This means like, I think this last half where we did this, like, I think this was really helpful because you had the code and maybe the code was confusing because it's new, but then you could translate it to what the visualization is doing. And you could say like, okay, this is making this do this. And so I think that was really nice to be able to see that relationship between the code and what it's doing. Cool. So so
we'll do more of that.
Okay.
Yeah. Perfect. Yeah. Listen, we do what we got to do.
Okay. I don't know. Maybe everyone else is like, this is too easy, and I'm sitting like, oh.
I don't think so. Like, listen, I remember because like I'm looking back to like when I first started coding, and like every single, like when you take a programming 101 class, like, and like, I don't know, maybe we should have done this, but like the very first is like you do your hello world program. And it just means like we kind of went it over because we compared like Java and Python. It's like, oh, like how would you create a program that just says hello world? And yeah, that's like how basic some things are. So listen, again, other people have never seen Python either. So I'm sure there's similar feelings. And it can be a lot. It can be a lot. Especially, I know, like, we'll probably steer away from like the stats and machine learning because that, I think I like, even I personally, I was like, I told Nate, I was like, oh, like this is like for a Python 101, I would not expect that. So we'll probably
I
steer
think
away from that.
too, and I don't know, and maybe this is because I was going to ask too, like as me personally, and I guess this group is like the whole idea is we are potentially like wanting to go into this field as a junior level, I guess, business analyst or data visualist, which I think is kind of where my brain is more, but whatever. So it's like I want to know, like, what am I going to be expected to do? And so I think like, getting into like here, stats and machine learning, I'm like
No.
what are like
No.
what all am I going to be asked to do? That's what I want to learn. I don't care what, like, this sounds kind of like, I don't know, like snarky, but like I don't really care what's possible if I don't know how to do the basic things. Do you know what I mean? And when I've tried to learn on my own, or when I try to, I'm like, okay, let's get confident in like the baseline, so then we can keep growing. That's how I am for myself. And some people are better. They want to know all this stuff and then pick it apart. And I'm like, I get overwhelmed by too much stuff. So
I think that makes sense for sure. Yeah. But I will say, like, from my experience and from what I know from like my peers, because my first master's is in information systems and operations management, which it basically teaches you to become a data analyst. Like that's what most people, they become either like a consultant, but my very first job was as a senior business intelligence analyst. I knew how to code. I was not asked to code. So like to become even like a data analyst, I don't even know like if you're expected to know Python necessarily. Like I honestly think like, one dashboarding software, Tableau, Power BI, IBM Cognos, if you're really sad, that thing is terrible. Or then, and then SQL. And honestly, like, and Excel, like, how to handle like database stuff, like, how to do queries and stuff. And then how to visualize them. And you don't have to know how to visualize them in Python necessarily. And the job posting is gonna tell you like if Python is expected, but like if you go, I would say like go check out like couple of like, let's just say like your target companies or whatever, and see what their job postings are expecting from a data analyst or a product analyst or whatever. And some of them might expect you to do Python, but I feel like most don't. And maybe I'm so far from it at this point that I'm incorrect, but that's just from my experience.
Well, and I kind of wondered too, like, how is it just based on what the company uses, or like, because if we're learning SQL and some of it is similar to Python, and then even with this, like, oh, I'm generating visualizations, and I'm like, well, I feel like I could do that in Tableau already. Why would I use Python? Like, what's the like, what, I don't know. I guess like in what circumstances would you use one or the other? Is it just like, well, the company uses this, or?
I do think like availability, because like Tableau is not the cheapest product to own. Okay. So like if you were to go to a smaller company, I mean, there's so many like different visualization tools. And like I feel like a lot of them do give you like the freedom to like, hey, like, can you make a dashboard? And they don't necessarily care how you make it happen. But that you might not have a Tableau license available, which you won't be able to use Tableau. So in that case, okay, do they have any other ones available? Can we use Power BI? Can we use, I think like Google Cloud has some kind of dashboarding. I forget what it's called. That's even free. But that's kind of like, I think, where it falls in. And like looking at, so I'm mostly a software engineer. Like I worked as a backend engineer. So when I applied to like jobs, they don't even care like what language you know. They just want you to know one language really well. And like, so when I worked at AWS, I had never coded in Ruby. I had coded in like JavaScript, which is very similar to TypeScript. So like that was like easy enough transition. But And then they also use like Golang. Never use that. And you just kind of like pick it up on the job type of thing. And like, especially if you go to a bigger company. So I worked for Verizon. That was my first job after my first master's. They literally say like, oh yeah, nobody expects you to do anything for the first 6 months. So like, they're just expecting you just kind of like learn and pick up whatever, like you see what everyone else is using and whatnot.
Okay.
If you go to a startup, your experience is going to be wildly different. But if you go to like any of these, and especially if you go to a big non-tech company, like you go to like healthcare, like Walgreens, CVS, Home Depot, you'll be completely fine with your current knowledge. Like, I promise.
See, that's just so bizarre because I'm like, I hear that and they're like, it's like, oh yeah, no, it's fine. Nobody like, and I'm like, okay, but I really don't feel like I know. And then I really want to be in a situation where I'm like literally a junior and I have a senior who I'm learning. I want to learn processes, best practice. I want to get very, very like comfortable in the like how to do it. So that way I can keep learning and get better. But I feel like in everything I've done before, it's just like, I haven't been able to learn. It's like, oh, well, now everyone's using a new platform. So you have to learn something brand new. And I'm like, okay. So yeah, I was just kind of like, I kind of want to wrap my head around like, what should I focus on? Or like, because like, if I know Tableau, is it reasonable that like they use Power BI? I could probably do it without a big issue. Okay.
100%.
That's kind of where I feel like I can cross over on things, but I
the
just
whole
like interviewing for these jobs. It's such a different, I mean, it's not that different because I have been kind of like a dev designer, but like not in this way. So I just don't know what.
I think the whole like what it boils down to is like, do you know what you want to do? So like, again, like, so like I've never had code in Ruby, but like I know the basics of coding and like, you know, like loops and functions and whatever like you're trying to do. So like you want to know like what you can do, what you should do, what you want to do. So like if you're given a data set, do you know what to do with it? You don't need to know exactly how to do it in Tableau, but do you know what you want to do?
Right.
And at that point, it doesn't matter if you're using Tableau or Power BI. You know what you want to do. You can Google it.
Yeah.
But if you don't know what you want to do or what you should be doing, then you're just like, it doesn't matter what you like, what you know how to use if you don't know what you want to do. And again, like, I think for like when it comes to data analysis and like visualizations, like knowing what brings value, like what insights do we care about? And like, listen, some of these examples are not the best, honestly. Again, I'm just like showing like, this is how we do these graphs, but are they really bringing value? Not necessarily. So like knowing what is going to cause change in like operations or like how we do things. Like, oh, sales are down. Okay, why are they down? Let's go figure out from the data, why are they down? Is it the like whatever, like marketing campaign is not doing well enough? We're not getting enough clicks from our email marketing, or like the package is not working. So like that's where we're going to bring in the data and we're going to look at which marketing channels don't work well enough. But if you don't know what you're looking for,
right,
it doesn't matter how much you know how to use Power BI if you have no idea what you're doing. So that's what it like kind of boils down to. Like, how do you problem solve? Do you know what you want to do?
Yeah.
It's like, you know,
that's what kind of like, even though this is sort of a different area, I was like, I feel like this connects to what I've done and why it's interesting to me still, even though it's a little more like drier than what I did before.
Yeah.
But I like being able to like problem solve. And so I like that aspect. So
yeah,
well, I've taken more of your time than the class. So
I would say one more thing, what you were saying about like kind of like qualification thing. Like these have been like proven with data as well, that like women especially, they are not going to apply for a job until they feel like they meet 100% of the qualifications. You need to channel your inner white man, because they're going to apply when they like meet 50% of the qualifications, and they probably still get hired.
Well, yeah, I totally get that. And I've definitely worked through that in my job search in the past year. This is like a brand new skill set though, so it's a little bit shakier.
Yeah.
But I'm
Yeah, but you already know Tableau. You already
yeah.
know SQL.
Like if
Like
I just
that's what I'm
focus
saying.
on Tableau, I think I'd be fine. SQL is like I'm mostly good. Python will get there. I think doing the project will like be like, oh, okay, because I'm actually applying it, so I think that'll be okay in the end. But yeah, that's
I
why I'm
think
really glad there's internships to kind of like have that experience where people know where I'm at skill wise and experience wise, and so
I think like knowing Python and R, it's just kind of like I would like if I were to hire for a business analyst, I would or like data analyst or whatever, like I would put like, oh, Python preferred or R preferred, because that's just gonna be like a bonus thing that
sure.
like, oh, we can do like extra statistical analysis or like very custom charts or something like that.
Mhm.
Like I don't know if I would necessarily require it. And
Yeah.
again, maybe I'm completely incorrect, but that's just how I kind of see it. And I feel like, and that's what like when I worked at Verizon, they were like, oh yeah, like we know that you use this there's like a tool called UiPath, which does like robotic process automation workflows. And they're like, oh, like, do you want to do a certification in this? And like they were willing to put me through the certification
Yeah.
to learn it for a project. So
Yeah.
I think that you see that a lot. Like
that'd be
they
awesome.
want to teach you their ways and stuff. So
Yeah. Okay.
you'll be perfect.
Okay.
Okay.
I kept you over. I appreciate your time.
No problem. I just want to make sure everybody succeeds. Everybody
Yeah.
feels good.
You. All right. Well,
We'll
see you next week.
Yep. See
All
you
right.
next week.
All right.
Bye.
Bye.